Welcome back to Forge College. In our last lesson, we walked through the glossy front doors of Web3, looking at how to engage with community projects through front ends. Now it's time to sneak around back and look under the hood of an actual transaction. If you've ever pictured an Ethereum node as some incomprehensible, glowing black box of math, let's fix that. Think of it more like a highly efficient, decentralized city hall. To understand how Ethereum ticks, and specifically how it differs from other blockchains like Bitcoin, we have to clearly map out the distinct departments inside this building. Mapping these technical terms to everyday bureaucratic functions turns a chaotic global network into a highly predictable, intuitive workflow. Let's step inside. Let's start on the ground floor. This diagram shows our first department, the mailroom. In Ethereum, this is the peer-to-peer, or P2P, network. It constantly receives a chaotic influx of incoming digital envelopes, our raw transactions. The P2P network has exactly one job: deliver the mail. It moves transactions rapidly into the node, but it doesn't actually open the envelopes or check what's inside. They just pile up at the doorway, waiting for the receptionist. In technical terms, this is the transaction pool, or TX pool. Here, the TX pool actually opens the envelopes. It checks the digital signatures to make sure they're valid, and it reads the sequence number, called the nonce, stamped on each form. The receptionist is a strict stickler for order. If application number 4 arrives, but the node hasn't seen application number 3 yet, the TX pool puts number 4 in a pending tray. It sits there, paused, until number 3 finally shows up. Only when these forms are perfectly sequenced and fully validated do they get a stamp of approval. Now they are eligible candidates for official processing. The T-pool acts as a vital buffer. It protects the rest of the node by filtering the absolute chaos of the open internet down into a strictly mathematical, perfectly ordered queue. Next, our sorted documents move upstairs to the processing office. This is the execution client, which houses the Ethereum virtual machine, or EVM. The execution engine takes those validated applications and runs the actual math. It executes the smart contract rules, updates the numbers, and spits out a receipt proving the work was done. But doing the math isn't the same as saving it. For that, we need the archives. This is the state database. It organizes every account and balance into a branching structure, like a massive verifiable family tree of data called a state tree. The execution client connects directly to this vault. It permanently logs the newly updated account balances and contract data into the state database for future reference. So, while the T-pool simply organizes the incoming requests, it is the execution client and the state database that actually do the heavy lifting, officially rewriting the permanent reality of the blockchain. Finally, we reach the top floor, the City Council. This is the consensus layer. The council's job is oversight. They vote on a block of executed transactions, cementing them into the single official timeline that everyone agrees is the truth, what's known as the canonical chain. Notice the strict division of labor. The execution office proves the math is correct, but as this logic gate shows, consensus decides which mathematically correct block actually becomes the official timeline. A transaction is only fully final when the office completes the work and the council accepts the agenda. That double check eliminates any chance of conflicting records across a global network. Let's zoom out and look at the entire architectural map. We have a clear 5-part journey, from the chaotic P2P mailroom, through the T-pool receptionist, up to the execution office, saved in the state archives, and finalized by the consensus council. Decentralization relies entirely on these strict, distinct boundaries to create a verifiable, step-by-step sequence. Hold on to this specific blueprint. In our upcoming capstone lesson, we'll use it as a side-by-side reference to see exactly where Bitcoin's architecture takes a different path. If you want to review this workflow or explore other educational resources on Web3, visit us at forge.college. Seeing this internal workflow makes it clear why different blockchains diverge so sharply in their design. Thanks for learning with Forge College.